works. Thanks, everyone. I just noticed Dan's wearing the company T-shirt. Me too. Like good person working technology. Never need to buy your own clothes ever again. So yeah, I'm Cynthia. It's very honored today to talk about one of the, I guess, the fundamental concept in engineering a service is observability. And today we'll probably focus is specifically on the domain-driven design aspect of how to design the observability to fit in this scope. So brief introduction. I'm Cynthia. I'm a software engineer at the Trade Desk, and then joining me today is Ruilin. Ruilin, you want to do a quick introduction?
Hello, everyone. Can you hear me okay?
Yeah.
Cool, great. Hello, everyone. I'm Ruilin from geo-targeting team in the Trade Desk. I've been working here for about 2.5 years now, based in Sydney office. It's nice to meet you all today.
Yeah. Cool. Yeah, so the agenda for today, so first of all, we will mainly talk about the concept of observability, what it is, why we need it, and then we'll touch base on the observability aspects that we should consider in a domain-driven design architecture. And then Ruilin will take a deep dive through the stories of our own success and challenges in applying the observabilities in our microservices at the Trade Desk. So before I dive into the observability piece, I would love to introduce just a bit more knowledge about programmatic advertising. So that, because Ruilin's example will use this, I guess, our projects extensively, this will help you to understand. So has anyone actually heard of programmatic advertising before this? No, great. Nobody heard of it. Blank canvas for me to paint. No one will know if I say something wrong. So I guess we all have the experience of using going to any sort of websites, news websites in particular, and you see those ads on the banner and on the side, and then you use our phone, play a game, and says, "Oh, you died!" Watch an ad to revive yourself, or all these video streaming services that's on demand, and then you got to watch the ad in the beginning, in the middle, towards the end, wherever it is. So these places where they can serve ads in the advertising space, we call them publishers. So they are basically advertising is the currency of the internet. It enables those publishers to monetize on their content with free users. So when you are not paying, you're the reason that people are paying. But the publishers, they don't have the technology to serve those ads themselves. So they usually engage a supply side platform, Google being the largest one in the world. Surely you've heard of that. So this is from the sell side of an ad. And then on the buy side, there are advertisers, usually companies like BMW, Pizza Hut, P&G, and they want to pay money for you to be able to see their product and service. They go to a marketing agency, they say, here's what we want to do, come up with a campaign for us to do it. And then they will come to a demand side platform, Trade Desk being one of them, and say, oh, I want to target females age from 21 to 35 who's interested in pets. And here is the budget, here is the ad, the content of that, we call it creative, and go serve it. And then, so this is the whole chain of every single ad you see is catered, personalized to you. It is big growing sector in the advertising space right now, as it's very cost effective comparing to the traditional type of advertising on newspaper or on linear TV. And then, so as you can imagine, how many people are using an internet connected device these days? So this connection, the auction that the supply side platform is hosting for real-time auctions, this is happening at least on our side. We get 12 million of those every single second. And then they are all real-time auctions. That means you can't pause anything for these ads to load. So they usually give you 200 milliseconds for you to respond to that, which minus the network latency, 100 milliseconds to respond, to find an ad, and then respond back to say which one's the matching one. So that, hopefully that gives you an overview of what programmatic advertising is about, and helps you to understand Ruilin's example later better. Sorry, where do I go next slide? There it is. So what exactly is observability is such a wide concept, consists of many different aspects. And for me, I think these four are like the most important aspects of observability. So the first one, I will start with the system health overview. It's really important to have a holistic view of your application, your services, like how healthy they are, what's the performance, what's the availability, like you need to know it to be able to optimize it and then to make it better. And the second aspect, which I feel sometimes people overlook, is the business performance. To be able to fund your services, fund your project, it's got to be proven valuable. And really to have these things in place to help you to the business stakeholder to make decisions, and then that further out helps your services to be better, to get more resources. Operational performance. Yeah, this is important to know because your services are probably going to be ongoing there. Like for you to know how much it costs for your services to run. Like, does it make sense to run on the bare metal? Does it make sense for it to run on the cloud? Or like even on a specific software, like so a database, for example, like so Microsoft SQL Server as example, it needs the licenses on how many cores your CPU has. Like when you need to scale that horizontally or vertically, like you need to make that decision. So does sharding make sense to make it like, smaller and it runs better, but it also takes a lot of engineering effort. So for all this type of analysis, you need data points. And least, but I guess very, very important aspects to identify and solve issues. Those Ops Genie alerts coming. So like really like how do you get alerted to route to the relevant teams quickly, then people can respond to it quickly. And so what sort of troubleshooting strategy that you're going to employ if something goes down unexpectedly. So for, I guess, 4 pillars for the observability, the thing how to achieve it is logs, metrics, tracing, and visualizations like dashboards and reports. I will talk in details about each of them. So logs, the ones you can burn or you cannot. It makes it has a lot of benefits to observability, as like it can create a historical records of all the events, the activities that has happened in the past. Then you can look into it. They are invaluable in troubleshooting issues and understanding what happened in the past. And then they also provide a lot of diagnostics. So you can look into it about detailed errors, warnings, significant events. And they also use for security auditing. So if there's any security related breach events that you can record all of that. But there are also things that you really need to look out for using logs. First is volume. So because when you log some events, that it is important for it to have a very rich context. And then thus like each log items may become pretty big. And then if you log it in a system that the code always getting hit, that you really need to watch out the volume because it's gonna take a lot of storage space. The trick here is to be able to make your logging configurable on every single level, preferably, so that you can turn them on and off to be able to control that. So sensitive information such as email address or driver license numbers. You don't want to log those for legal reasons. It's good practice to have a centralized logger where in the logger itself, it filters out those type of informations so you don't get yourself in trouble and the company. Search complexity is another thing you need to look out for because logs are very, as the volume grows, it's really hard to find the relevant things. I think the tips I would give here is try not to reinvent the wheel and then use a tool that's already readily available, and so that it can save you engineering resources to focus on the features and otherwise. And real-time visibility. So logs usually don't provide real-time visibility. If you want something real-time that you need to consider something else, is usually used for you to look at what has happened, not what is happening. So tools that we have used at the Trade Desk for logs, files, I'm sure all of you use files. Yeah, so a lot of the log files get uploaded to the cloud, like to S3 buckets, for example, and then get processed somewhere else. Windows events is overused in the past as well. Before we transitioned to running less stuff on Windows, we used to also upload logs into a particular database, but then now we moved away from that for the search complexity reason to sumo logic. And then a New Relic is used for any front-end client-faced services. So Matrix, Matrix is it's very small to store. So it is a very good way to get a real-time insights, and then you can aggregate it as well. So that you can see trend analysis. So this way you can have good visibility into the health and performance of your system very easily. But things that you need to look out for using Matrix. Matrix has very limited context as it's just one number out of many different aspects. And then sometimes sampling is used as well during collecting the matrix because it could be really a lot of devices are sending it. So you could possibly be missing transient issues for using matrix only. It also could add to system overhead and operational cost. We use Prometheus, and then Prometheus charges based on how many matrix you store. And then for some matrix, you have a lot of different dimensions, say machine name, and then you have thousands of servers, and then you can add in your labels as well. So for each dimension you add, it multiplies and multiplies, it grows really large. And then for every single matrix you add, and then the cost goes up really quickly. So you really need to start simple and small, really ask yourself, does this thing make any sense for us in a business need, to have this matrix? Otherwise, might need to think about other ways to store them that you're not wasting money on having heaps of numbers running everywhere. And as I said before, we use Prometheus. It's also a learning curve to use the PQL as a Prometheus query language to be able to design how you want to view your metrics. Tracing, as from the name suggests, you trace from one end to the other. Especially, it's important in in domain-driven design, a lot of microservices are used because you want each service to represent each business function. And then to be able to trace something from the beginning to the end, you need that visibility. It can be used for latency analysis, and then to find out in each component of the call how long it takes, and then so you can optimize it. And you can also use it for a root cause analysis to see exactly where it is broken. Things to look out for is similar to logging, is the volume of the data that you're tracing. And then also, instrumentation has its own complexity as well. It's usually not a lot, but it is something that you need to consider as it is adding the complexity in development time too. So tools that were used at the trade desk for tracing is Sumo Logic, New Relic, and then for the SQL specific, for Microsoft SQL Server specific, like tracing that we use the Microsoft Server Management Studio for profiling thing. And dashboards and reports, these are great for you to be able to visualize all the stuff that you collected. We mentioned previously, especially metrics, and then you can customize it to look exactly where you want it to focus, and then you can use it to build up alerts and then all the troubleshooting guide and all of that as well. So things to look out for is sometimes these things goes out of date fairly quickly. That you really need to put in the effort to maintain those. And then, as I said before, like the Prometheus query language, or things similar to that, there is a learning curve to know how to learn it, to see how best to use it, to be able to build the dashboard that represents the best about your needs, so what data you look at. So for this, we usually use Grafana for all the backend of our services, and then New Relic for the one that touches with the client. So after all that, thank you for listening to me mumbling. So is there anything that you need to consider specifically if your architecture is driven by domain? Because microservices are usually used often. And yes, I think the first thing I would talk about is how do you design your metrics to be able to, for your services. Really need to look into it from a few different persona. So if you're a business stakeholder, what do you look into, like what impact is your services making, and then how can it help you to make decisions in the business? If you have two type of features in two ways, how do you do A/B testing? How do you compare which way is better? And sometimes these questions need to be asked early during design phase, because it's hard to collect some of this or change it to collect some of this information later on. We've had examples of maybe we didn't think something through about the business impact, and then we made a solution, and later on it was hard for us to adding that type of things to collect it. And then from, I guess, the engineering perspective, the main, I guess, the one that's making the services, like consider from performance, response time, and availability, like to ask yourself what you want to know from, like, to maintain the health status of your own service. So for DevOps, similar to what we talked about before, the usage, the cost, and if is it cost efficient for it to run this way, or is it better to run another way? Like, you need data points to know that. And database too, it's very similar to DevOps, like really like how much storage that you're taking. Like, there are different types of database that you might be using in your services too, like the could be using the NoSQL, like the key value pair type of database. Does it make more sense to use that? Does it make more sense to use a relational database? All of this helps to make that decision based on, like, the type of performance, the exact areas of what you needed. And then another thing we often use in microservice architecture is about this logging and context propagation. Like, because there's so many services initiated by one customer call, when you want to trace it, you really need to know where it goes. So it helps if you have a correlation ID, and the ID is used throughout your entire stack, across from the top to down, so that you can know exactly where it's been through, and then collect all the events related to that. It makes it easy to filter. And you could also have something like a trace ID and the parent ID to work as together as well, to generate a trace ID dynamically on the each of the call, and then to pass it down, and then so like it becomes a parent ID of the next call, and then you can map it up to in that way. So another thing you might encounter, because microservices are usually owned by different teams, there is ownership could be something aspect that you need to consider in the observability. Like, where do you route your alerts? And then is there enough documentations and trainings between different teams for like if something goes wrong, and then can someone else outside your team to be able to troubleshoot it quickly? Like, are you providing enough information for your services and applications? And then also code quality across multiple different repositories owned by multiple teams. Sometimes this goes quite sparse. Like, how do you ensure a consistency between the different teams? So like for us, I think we currently using a tool called Sonar Cube that helps. It can be configured to scan your code base and scan each of the pull requests or merge requests that you have to see what you're introducing. Is there any vulnerabilities? And as such. And that concludes, I guess, my part of the talk. And then Ruilin, I'll pass over to Ruilin to continue deep diving into one of the examples we have.
Cool. Thank you, Cynthia, for lining out the landscape for us. Hello again, everyone. Now I'd like to share with you a closer look of how we've implemented domain-driven design and
Sorry, Ruilin, can I just interrupt you for
yeah,
1
sure,
minute?
sure. No problem.
Because we probably need to swap the screen share. What would be the best way of driving it? Because we're sharing the pack from here. Oh, yeah, I think that should work. Okay, then I can undo this. Sorry about that.
No problem.
Let me know when you need next slide. I'll be here.
Yeah, cool. Thanks. Okay. I will share with you a closer look of how we've implemented domain-driven design and observability in practice. And we've applied them actually broadly across our platform. But to give you a clear picture, I'd like to zoom in on a particular chapter from our team story. Next slide, please.
Sorry, one moment.
No problem.
I can't find the. Oh, here. Yeah.
Oh, cool. Great. Firstly, I'd like to briefly introduce what is geo-targeting. Cynthia has introduced this before in the beginning, just for a quick recap. Imagine there is a travel agency aiming to promote their travel insurance, approaching us with specific requirements, like they wish to connect to individuals aged between 20 to 40 who has interest in both financial planning and traveling, living in either Sydney or Melbourne. Out of multitude of auction requests we receive, if we can identify an individual within the age of like 24 to 35, living in Melbourne and showing interest in both financial and traveling, we consider it's a match. So we have a specialized team focusing on different dimensions, and our geo team concentrates on identifying an individual's geolocation. Next slide, please. Thanks. So in our geo domain, we mainly have two responsibilities. First is resolving an individual's geographical location, and the second is maintaining a comprehensive list of geolocations that our customer can select for targeting or even blocking. Given our global reach, it's crucial for us to have capabilities to determine geolocations worldwide. Next slide, please. So to execute these responsibilities, 2 years ago, our Geo team started to design a new Geo microservice. We identified 4 crucial requirements that we need to consider. First is diversity in Geo provider. Next is speed. Next is privacy and maintaining up-to-date data. I will break down each of these requirements one by one, talk about how we use domain-driven design and observability to navigate these requirements and keep things running smoothly. Next, please. So to resolve user location, we basically have 3 data sources. The first one is to resolve the user's IP address to a geolocation. This is the most common way, as IP address is most readily accessible data we have. So another is using latitude and longitude coordinates. And alternatively, we sometimes have location information directly supplied in the auction request we can use. Then we use these data sources, querying data from our third data providers' data to convert those IPs, coordinates, or location names to a unified location ID, which can be then used for targeting or blocking during the auction. And there are different third-party geo providers on the market offering different features, and we need to smartly integrate multiple data sources to optimal the results. Next, please. So now taking IP as an example, for just IP to location info alone, we have multiple third-party geo providers offers different information to link IP ranges to locations. For instance, according to the first provider A, they range 1.0.0.0 to 1.0.0.255 could be associated with Melbourne, and another range 1.0.1.0 could be Bondi. That's from provider A, but provider B might have different data and also associate these IP ranges to different locations. Next slide, please. So imagine we receive an auction request with the user's IP 1.0.0.101. Using provider A's data, we might say, okay, it's from Australia, Victoria, Melbourne. However, with provider B's data, it is same Melbourne, but it's represented in different format, like Australia, Victoria, Melbourne inner, and Melbourne CBD. As people may prefer different providers in different regions. Like in Australia, we may prefer provider B, but in the US, people may prefer provider A. And we are using provider D, probably we are using provider A right now, but we want to switch to provider C next month. We don't want our system to be limited to one provider. So in our new Geo microservice, we aim to integrate multiple providers' data. However, the challenge is showing here, there are discrepancies in location structures between different between different providers. So when our clients want to target Melbourne, we can have them to pick from different lists for each provider. We can't tell them, okay, we are using provider A now, but we are going to switch to provider C next month. Please pick our location you want from the new list again next month. So we need a unified location. Next, please. So that's where we need to work closely with business team in each area to choose the better location structure. Then we designed a data transformer here to transform location information different in different regions. And we maintain information logs for this transformer, detailing the number of locations transformed in that transformer and the reasons behind each transformation. And they are all monitored using Sumo logic to ensure clear observability in our system. Next, please. So now, let's say we get another auction request with the user's IP 1.0.0.0. If we use provider A's data, it tells us it's from Melbourne. However, if we refer to provider B's data, it says it's from Sydney. Such discrepancies can occur as different providers may have different data sources, and the IP addresses can be quite dynamic. So this poses another challenge. One provider might link many IPs to Melbourne, giving us lots of auction requests when so when our clients want to target there are tons of auction requests there. But if we switch to another provider that links just a few IPs to Melbourne, so certainly we have way fewer requests to work with. That's bad sign. Next, please. So that's why we've developed a tool to visualize this shift. Using data from the past 7 days to create a heat map. And this allows our business team to visualize changes clearly. And this screenshot is for the United Kingdom. The lighter color on the heat map shows where we get more potential auction requests. And we also offer another detailed impact analysis report, providing precise figures on traffic at campaign level or at location level. This has been crucial for us in smooth transitions between providers. Next, please. Okay, that covers our discussion on geo-provider integration. Now let's move on to our second crucial requirement, which is speed. The duration of blink is about 100 to 150 milliseconds. Given that we only have around 100 milliseconds to respond to an auction, and each auction may have thousands dimensions, not just geo. Remember in the previous example, there were like ages, interests, maybe income, and so on. That's why we need to resolve location in sub-milliseconds. So to achieve this, we used our internal mechanism to build a lookup index, can combine IP and location data from multiple providers. And this system is designed to take an IP address as input and output and a standardized location in less than 0.1 millisecond. Next, please. On the left, there is a Grafana screenshot showing the response time of our IP index across different data centers and jobs. The times can vary, but they are generally under 100 microseconds, and with most of them being less than 50 microseconds. And on the right side shows our latitude and longitude index response time, also under 50 microseconds. And there is also a request count, which is about 10 million requests per second we receive. And we use this to ensure our system is running efficiently. Right? Next, please. Okay, now next let's talk about the privacy. We must adapt to different privacy requirements across all regions, and we deployed a variety of strategies to address these requirements. These include masking IP address we receive, and in such cases, relying on alternative sources for geolocation. And there are instances where we must drop specific location information. And we've also set restrictions on the minimum targetable area size. Next, please. So when we're using latitude and longitude for targeting, we inform a default minimum area restriction, preventing clients from targeting circles with a region smaller than 100 meters. But in the US, the rules are stricter. In such scenarios, we collaborated with our business team and the legal team altogether, and we designed a configurable solution for this use case. Next, please. Again, for this one, we maintain a dashboard on Grafana to quantify the impact of those area limitations and showing how many target areas have been affected by those constrictions. Next, please. Lastly, let's talk about maintaining up-to-date data. While location information remains quite static, the reality is the correlation between IP and the location is quite dynamic. So data provider typically update their data once or twice per week. We have a scheduled job to detect all those updates, and when an update is detected, we transform the new data from the data provider to our standard format and store it in our database. Then we build an updated index and deploy it to production. This ensures that our geolocation data remains reliable and accurate, meeting the dynamic needs. So here is a graph showing the age of our data. If the line rises significantly, say more than 4 days, it's a clear indicator that something has gone wrong. So we also have alerts to notify our team where our Slack channel for those cases, and ensuring immediate attention or resolution to maintain data accuracy and reliability. Next, please. All right, we've reached to the end of the presentation. To briefly recap, we've explored how our geodomain works, from mixing different data sources and maintaining speed, to respecting privacy and keeping our data fresh. Hope this gives you some idea on how to apply domain-driven design and keep a close eye on your system with observability. Thanks a bunch for listening. We are open to any questions, comments, or thoughts you may have.
Any questions?
I have a question.
Yeah.
So on one of the slides, when you were talking about metrics, you were speaking about metrics and then relating it to behavior. What kind of metrics what kind of design considerations do you think of when designing metrics that help understand behaviors?
So, like, sorry, could you rephrase it?
Yes, I was probably thinking and phrasing it at the same time, so I'll repeat. I guess what I'm trying to understand is, while you mentioned when you were talking about metrics and you were relating it to understanding behaviors.
Yeah.
I was just trying to understand what should we think about when we're trying to design good metrics.
Yeah, I think this really varies from case to case about what exactly your services does. Like in Ruilin's example, it would be to really understand to really think about from the impact of your services that you change, you feature, from both a business perspective and a technical perspective. So for the business perspective, you need to think of, if I make this change, I have this thing like who are the stakeholders who I should talk to make sure they're informed of the changes coming, and then how do I manage the relationship with them to be able to like, I guess, onboard the business stakeholders to answer any questions they have, like before, during, and after the rollout of particular features. Otherwise, I think is quite, I guess it would be more standard than the business side, that you really understand the typical like aspect of performance, the availability, and then the cost type of things. Yeah. I don't know if that answers.
It did, yeah.
Yeah. Anything else?
Yeah, I have a question for, sorry.
No, Chris, you go ahead.
For Ruilin, you talked about collaborating with some of the other teams in the business when you're designing some of the metrics, or I guess handling some of the constraints. Could you talk a little bit more about the way in which you collaborated? Like what kind of techniques did you use to explore, the consequences of some of the design decisions, or to understand their needs and the way they understood the problem?
For this one, I think the most important part is just communication. We need communicate with the domain experts and also from the technical side experts to just sit down together to talk about, like, really brainstorm to talk about what could happen after, for example, after we change to another provider, what could happen, and we build some tool, maybe some model to simulate that and just predict the results. Not sure if it answers your question.
Yeah, no, that's great. I really like the modeling approach, creating models to help people understand the consequences of things. That's really cool. Thank you.
Cool, thanks.
Question around, the auction thing you talked about. How does, for example, if your servers and there's an outage in the system, how does that impact for your business in terms of their customers? Is it are there compensations built in, or how does this? Excuse my ignorance, because I don't know much about this world of advertising and how this works. I mean, understand IP and everything, but how does this auction thing gets worked out if there's an outage?
Yeah, so usually if the outage is not too bad, a few servers, that doesn't impact the business at all. Like a few servers are down, we just spin up some more. But on the case that some major component goes down, depends on what. So for example, a whole data center goes down, and then the backup data center also goes down. The impact it would have is for each auction, we cannot make accept new auctions anymore, which is okay most of the case because the campaign usually runs for quite a while, so that you can later on to increase the bidding to be able to pick up that budget. But for the case that, I guess the other part that would be impacted is so when we win an auction, we need to record it. So if that component goes down, that we can't record or win, we actually won. So there will be a discrepancy. So on the internet, that happens quite often. So naturally, I think there's a percentage of discrepancy accepted by the client. That's the whole industry does it. But on the case, if it were like the company's fault, like our thing went down, that this particular period of time that there could be some like estimation and makeup for that.
Thank you, because I think that's what I was trying to understand. Because in this service-based systems, there are compensations built in, and that's why you have redundancies of the service.
So everything is heavily redundant.
Yeah, but there is a reconciliation error that you just mentioned. And that's what I was interested in. Financial institutions also, especially in stock markets and stuff, there's reconciliation happening.
Yeah.
And it seems like the volume of data of the transaction happening is very similar, or in fact, even more, I would say, than it's happening in trading and stuff.
Yeah, like
we all are on phones and viewing something, so my brain's going, that is a lot of money lost if there's any downtime.
the thing is though, between I guess high frequency trading space and us is quite similar. But the data volume is, I guess we are bigger, but also the internet advertising space is more fault tolerant. Financial type of related thing, you strive for exact correctness, whereas on the advertising space, because the internet is so, you can lose so many things, like the whole ads from the beginning to the end, and needs to serve it, and then someone click it, watch all these events, they all tracked. Something could go wrong, and then so yeah, there is a industry accepted discrepancy rate. Yeah.
And do you see a trend, and this is the second question if I can, a trend happening where more people are either going to VPN and they're trying to find ways to block their IP addresses or come through? Is that changing? Is that a bit of a threat to the industry of how things are changing from a user perspective?
Yes and no. I guess we are always trying, like they are third-party providers we use to mitigate some of those. And then I think that's not the major part of what is impacting. So cookie going away might have some impact, but then there is, like, we are making like a whole industry-wide solution. It's called UID2, like this for every single one company in the programmatic advertising space to be able to integrate. That would not make it easy to not to use cookie at all, to identify not personable information, just identify an ID associated with a particular device or someone like that. Yeah, so there are like more technologies coming up to be able to adapt to this changing landscape.
Always a catch-up game.
Any other questions?